Our next concept is the pH scale. And this is something you've heard about in other classes. Probably never examined rigorously yet. We're going to examine it rigorously now. Okay? So pH this abbreviation pH stands for, why it's written this way, stands for the power of hydrogen ion. In other words, how strong is that concentration? Okay? And the definition. pH equals.
Wait, are you going to that bar room?
The negative log of the hydrogen ion concentration. Specifically, this is log base 10, not natural log. This is an E. Okay? So the pH is negative log of H+. Put a red box around that. That's something you will use frequently. Okay? So, negative log of H+, implication. High concentrations of H+ will result in what kind of pH values? High concentrations of H+ will result in what kind of pH values? Low pH values. High concentrations of H+ result in low pH values. Okay? Here's an example. Concentration of hydroxide ion, or hydrogen ion, gosh, I'm doing a lot today. Concentration of hydrogen ion is 0.10 molar. What is the pH? Get your calculators out if you need to. You've all got them, right? Negative log of that concentration. 1? That's what you got as well, right? Everybody get 1? pH equals 1. Okay? So, this is a fairly concentrated solution. 0.1 molar. This is about 10 times as strong as the concentration of hydrochloric acid in your stomach. So that's pretty concentrated. On the other hand, the concentration of H+ is, let's say, 1.0 times 10 to the minus 5th molar. The pH is going to be It is going to be 5. Okay? Higher number represents a lower hydrogen ion concentration. Okay? So, what is the standard concentration of hydrogen ion in water at 25 degrees Celsius? It's 10 to the minus 7th, so that makes the pH 7. Okay? Now, is water inherently acidic or basic? Both or neither. Either answer is acceptable. Water, we would say, is neutral. Okay? So, let's add a bit to our discussion here. Okay? So, pH so, if pH is, let's say, less than 7, okay? In other words, a small number, what will that tell us about the nature of the solution? It has a high hydrogen ion concentration, it will be acidic. If the pH is greater than 7, then the concentration of hydrogen ion is very low. The concentration of hydroxide ion is going to have to be higher. So this solution would be basic. Or what's the other word we used for basic when we were learning way back in honors about the different families of elements? Specifically groups 1 and 2. Alkaline. Basic or alkaline means the same thing.
Is there a fancy word for acidic?
Not to my knowledge. And of course, if it's equal to 7, then it is neutral. Okay? So, you can determine whether a solution is acidic, basic, or neutral by determining what the hydrogen ion concentration is. If it has a high concentration, it's going to be acidic. If it has a low concentration, it's going to be basic. pH of 1 is pretty strong, pretty corrosive. pH of 2, which is, it's a logarithmic scale, so pH of 2 is 10 times as dilute as pH 1. Or to say it the other way, pH 1 is 10 times as strong as pH 2. But pH 2 is what your stomach is. Unless you've had something really nasty for lunch, it might be higher. At least feel that way. Typically, though, pH in your stomach acid is about 2. That's pretty strong. Okay? All right. Now, what about pOH? Yes, question.
Does the pH level of water change with temperature?
Not appreciably. I mean, because when you increase the temperature, you're still making both ions. And, yeah.
What was the point of the 25 degrees Celsius definition?
The point is, of the 25 degrees Celsius, where we're far back with.
So it would.
At higher temperatures, it may not make this concentration. It might make, say, 1.0 or maybe, 1.2 times 10 to the minus 7. But it would also make that same amount. Okay? So, that's the difference. Okay.